Hi, just a quick little repair video on this TV. It's my mum's TV actually. It's a really crap brand Soniq thing, you know, just a one hung low brand, and she said that it's been going on the blink the last couple of days, and she said there was a picture down the bottom or something and the audio was breaking up and doing all sorts of jazz like that, and the picture's finally gone now, but it does show a boot up picture. Anyway, I thought I'd take a squiz at it. I brought it back to the lab, and let's turn it on and have a look. Here we go. Now, oh, yeah, see? Now we're getting the boot image, which is interesting in its own right, because of course if something wrong with the power supply, like seriously wrong with the power supply, you wouldn't get that. So all of the display panel circuitry is working and all that sort of stuff, the on-screen menu, but the built-in digital tuner is not working at all. So, well, it's not displaying an image, but audio was coming out of the thing. So that's, you know, it's curious. It could be a power supply issue that is affecting the digital tuner or something like that, perhaps, but anyway, I don't know. Like, I can't get it to come up with the menu or anything like that, even with the remote, and my mum's been having trouble turning it off, so yeah, it's interesting. Fault, so it's not a complete failure, and that display, that boot image comes up every time, so I don't know. The most likely fault with these sort of things is always going to be the you know, the capacitors in the power supply is going to be a major thing. But anyway, that could still be the case, but it's got a HDMI input. So what I thought I'd do is hook up my Tagano microscope to the HDMI input and see if that actually comes up or not. Well, I've plugged in the external HDMI and I did manage to get a menu there for a second. So let's see if I can call up the menu again. Here we go. We've got it. So that's rather interesting. Why it's coming up now and the menu wasn't coming up before. So that could indicate, yeah, marginal power supply, something like that. But look, I mean, there's nothing wrong with that image at all. It is absolutely bang on. Here we go. Input source. Okay, HDMI 1. That's the Tagano microscope. I'm not sure if it supports the 60 frames per second. Input. No, I mean, we're getting nothing out of that at all. No signal. No, that's a loser. Aha, it was the Tagano microscope. I got myself a Raspberry Pi here, and it loads, it views that just fine, so it certainly couldn't handle the 60 frames per second. So anyway, this sucker is working. Geez, it's making an idiot out of me now. Well, it couldn't get the menu up before, but the menu didn't come up immediately when I powered it on. So I don't know, maybe some sort of, you know, hey, hello. Hello, we're gone. We're gone. Yep. Hello. Yeah, you can see the backlight is still on. But no, it's, yeah, it's flaky. It's flaky. I reckon it's got to be a power supply issue. Look, I can't even turn that off now. Oh, it's dodgy as this thing. See, well, where's the boot message? Ta-da! Oh, look, there's no boot. There's no boot message. I heard the boot on sound, but the boot message, no, zip. So there you go. If I try menu now, nah, look at this, nothing. So, yeah, it's dodgy. All right, I'm not going to muck around with this anymore. I reckon most likely, odds on, power supply issue. Let's take it apart. And for those playing along at home, there's your model number. And there's a few screws around the outside. Yeah, self-tappers into plastic, as you'd expect. There's the little arrow markers on there, so presumably I only take those out. And but there's other ones on the back here which don't. Oh, here we go. Some bigger ones. So that's in the side. These two are at the bottom. Yeah, you've got to keep track of the different size screws. Okay, there's a bit of fail on the arrows there. They didn't say these four had to come off, and it doesn't say if the stand has to come off or not. But Yeah, the stand has to come out too. Alright, one more time for the dummies. Yeah, bloody power cord is like fixed there. Oops, warranty void. Warranty void if removed. Yes, Gonski. You bet your ass we're going to avoid the warranty because this thing's out of warranty. So even if it was in warranty, who gives a toss? Alright, hey, we're in like Flynn. Check it out. I expected there to be another metal shield on top of there, but there's not. It's just a bloody angle bracket. Look at that. Unbelievable. Man, that is just... that's pretty cut price. Oh, this is a pretty lightweight cut price sort of thing. Anyway, processor board, power supply board. Let's take a look. It's a Megmeet brand power supply. Go figure. Single-sided board, common as you're finding these things. But at first glance, where's my little poker? The main DC filter cap on the input there. Basically nothing. There's no, there's no bursting on the rupture seam there. There's no expansion. It's not bulging. These other caps aren't bulging at all. There's nothing oozing out of them. They're just cheap one hung low brand caps. I don't know. They're Samson with an X. Yeah, not that great. Same with the digital down here. Nothing much happening on the caps down here, so that's fine. I mean, any issues are more likely to be up in the mains power supply up here, but on first glance, yeah, nothing obvious with the caps. Might have to get the ESR meter out. One thing that was interesting is that the main ribbon cable going off to the LCD coming out of the main processor board here goes up under the power supply, but look, they've got like another buffer board up there sitting between there, and then this goes off to the LCD panel. So yeah, it's like some sort of rebuffering chip for the long run or something like that. Meh. Alright, the first thing I'm going to do is use my Bob Parker ESR meter here. I was short the leads, zero that out, and let's measure the main DC filter cap here. So let's plug it on. It's an 82 microfarad 450 volt. And we're getting about 0.63 ohms, a rough chart on here. I mean, that looks like a good enough value to me. I mean, talking, 450 volts at around about 82. That's pretty much what I'd expect. So nothing grossly wrong there. And as I said, no physical deformity in the vent on the end of it. So, no swelling, no rupture or anything like that. So that's... you'd have to say that's good. Next thing you do is take that board out, because to access the other capacitors, we have to access the bottom side of the board, of course. Nothing visually wrong on here. I mean, I'm not... I'm looking for any blowouts in any of the ICs or something like that, but really, if there was something like that wrong, then, well, this thing likely wouldn't work at all. But we're seeing symptoms of, intermittent type symptoms that are indicative of a classic capacitor failure. So, nothing visually interesting on the bottom of that main power supply board. So I'll access a few of the secondary side filter caps over here and measure the ESR of those. And there you go. That's a 1000 mic 10 volt capacitor. It's basically a dead short at the 100 kilohertz that this thing measures at. So 1000 mic. It's bang on. Really, nothing wrong there at all. This chart's saying it should be 0.1. We're getting 0.01. Not a problem. And there's another 1000 mic 10 volt, and that's fine. Everything's... Oh, that one's a bit high, though. I mean, we're almost talking order of magnitude higher than the other ones. Now, that was that capacitor there. Now, curiously, that's a Chong brand, not the Samsung with a Samsung, or however you pronounce it, with an X, which these two are, which I just measured. And although that's not the same value cap, that's a 470 mic 35 volt. But according to the chart on here, we expect a same value of around about 0.1 ohms. But hey, you know, there could be nothing. That could be a red herring. I'm not going to chase that now. Alright, I'm fairly happy with the caps I've measured on that board. There's nothing grossly wrong. So, next thing, rather than jump straight into the digital board, I'm just going to power up this power supply, measure it on the scope. So I'm going to use my LaCroix AP031 differential probe here, set to 100 to 1 attenuation ratio. So if there's 450 volts on that cap, for example, then I'll only get 4.5 volts out of this thing, and I can measure that on the scope. Let's see if there's any ripple. So let's power it on and see what we get. And there we go. We're at 1 volt per division there. There we go. Oh, that was interesting. It just, it was mucking around there for a minute. There was a bit of ripple on that. And let me disconnect the power and do that again. I haven't actually switched the power on, so we're basically just in standby power mode at the moment because, be careful, this is live. Always keep one hand in your pocket. This power supply is going to stay on all the time because this is just a soft standby function. So you're always going to have that. So what have we got there? We've got 100, 200, 300 and something on there. There we go. We're getting a little bit of ripple on that, but yeah, nothing serious. So we'll have to power the thing up, of course, and well, I'll do that now. I'll press the standby button. Here we go. Boom. We jumped up. We're getting some ripple there. It doesn't look that bad. I can't see the screen at the moment because the damn thing's lying down. There we go. We've got some higher frequency ripple stuff. So I presume, yeah, there we go. I heard it boot up. So it's all booted up now, and we're getting some. You probably can't see that, but some high frequency ripple on that thing. There you go. And that's pretty much what you'd expect. So that's fine. There's nothing wrong with that main filter cap at all. And if you're curious to see how quickly this discharges, well, let me unplug it. And it's still holding a decent charge. Look at that. This is why you don't want to touch these things unless you've left them off for quite some time. And it's also recommended, you know, you put a dummy load across them or something like that, a big ass resistor, you know, calculated that you can put it across there and just drain that main filter cap. But look at that. That main filter cap, that has still got 260, 270 volts DC on there. That'll give you a hell of a belt. And of course, something like this proper high voltage differential probe is what you need to be safe measuring the primary side of a switching mains power supply like this. The secondary side, that's okay. It's A, it's lower voltage, and B, it's isolated, so you can actually use your regular scope on the secondary side of it. But that primary side, you don't want to go dicking around unless you got one of these high voltage differential probes. Worth every cent. And I'm just measuring another cap on the secondary side here. Yes, I'm still using my differential probe just because I can, and it's still hooked up. Yeah, 12 volt rail, no problems, no ripple whatsoever. So I'll probe a few ones that I can actually probe around here, but I don't really expect to find anything on this primary you know, power supply here. So it's more pointing towards the secondary, the processor board at the moment, which, you know, I was hoping. Rather surprised at that. The odds were much more that it was going to be the main power supply in this thing, but possibly not. Okay, I've measured another rail here, which is around about 25 volts. This is 5 volts per division, 5, 10, 15, 20, 25 volts. There's a 35 volt cap in there, and well, yeah, you can see the rail. There we go. It dropped a bit. I've now switched it off. That was on before. So now I'll switch it on and see it. Whoa, there we go. You can see it jump down a bit, but you know, look, there's no ripple on there. There's nothing wrong with that cap. I don't know, to measure all the other rails, yeah, it's a bit tricky, but geez, there's nothing obvious. Yeah, I might have to start going down to the processor board down here and checking out the digital rails on that sucker. Now, they have actually been relatively kind and labelled the power rails down on here on the silk screen. So there's, as we looked at before, I'm just going to measure, this is the 24 volt rail. It's nominally 24, but there's 25. There's nothing wrong there. This should be plus 12. I assume it's the same rail, same ground. Yep, it is. Plus 12. Plus 5 happening over here. 5.25. They've trimmed it to be on the high side, as you'd expect, and plus 5 volts standby. So yeah, rails are good. I'm not going to go through and measure the ripple on all of those, but geez, you know, not much wrong there at all. And this is switched on, by the way. The thing is actually powered on and displaying something. So yeah, under load, meh, those power rails are just fine. So can pretty much rule out this board. Okay, next thing we're going to want to do is just have a poke around at some of the internal rails on here. The SOT 223 packages there, they're dead giveaways at their local voltage regulators. And yes, I've checked, like the can of here is ground, is connected through the common ground. So you can just put one probe on there and just probe around to your heart's content. Alright, there we go, 3.3 volts on the output of that regulator. Don't even need to measure the input because, well, you know, 3.3 volts. It's obviously a 3.3 volt regulator, even though it's not marked. Exactly what you'd expect. So you just go around and probe 1.89. That's obviously a processor core voltage. Another 3.3 volt local regulator there. What's this one? 3.3. So they're all fine. I've got no problems with that at all. It'd be handy if they actually had proper voltage test points on this silkscreen overlay and, you know, allowed you to play around with these things, but and measure them, but they don't. There's a 12 volts. There's 5. There, a couple of points marked there. It's actually a few, just a little strap on there. So, geez, the power supply is fine on this thing. So, what's the problem? I've got no idea. Now this is interesting. Sorry, I'm looking up under the bench here, and look, there's a line on that display and it's flickering in and out. We've got no input signal. I don't know what source is selected there, but yeah, it's not a well puppy, that's for sure. There's something going on here. Don't know what. Whoa, you see that red? What the hell was that? And just for kicks, I'll get out my FLIR thermal imaging camera, more just to have a play around with. And pretty much the things that are getting hot are the things I expect to get hot. A couple of freestanding TO220 packages over there. They're mounted on the heatsink. These ones over here are power resistors, presumably on the main rails. They get pretty hot. Actually, it's not good from this distance. I was measuring like up to 70 degrees on those, and the digital part of it was, you know, you'd expect the individual regulators to be hot and stuff like that. So nothing out of the ordinary at all. And the great thing is you can generate an external signal source because it's got a 5 volt USB on here and a HDMI input. So you just loop your Raspberry Pi through that and bingo, look at this, see? There it is. You can see the menu for a minute, and then it's flickering. It's flickering, and then, oh, it really doesn't like that. Now, interestingly, you can actually buy this complete replacement board, the MIP 329FL or the MIP 320FL1 board on eBay. You get it for about $35 shipped or something like that. So there's actually quite a few people selling these. So they're obviously used in a few sets. But anyway, I can't find a schematic for it or a schematic for this particular TV either. So, you know, we're pretty much going to have to do without. Oh, by the way, a handy tip if you want to discharge these caps, you can actually use one of these meters if you've got one that has this low input impedance voltage mode. So you can actually just use that, and then, oh, can we see that? There we go. And then whack that across the main filter cap, and bang, 4.6. That was up to like, still up to like 50 volts or something like that. But now we've actually discharged it using the internal low impedance of the meter. So that can actually be really quite handy, not only for eliminating ghost voltages, but in this case, bleeding out voltages before you work on gear. Check this out. Taking out the main processor board, measuring the main filter cap here. It's a 470 mic, 35 volt, and I'm getting 0.15 ohms, which sounds okay, but according to the chart, which is still like a very rough guideline, it should be about 0.1. So that kind of is reading a bit high. I'll just swap the probe. Shouldn't make a rat's difference, but just verifying, yeah, 0.15 there. So I don't know, considering that I don't have any other leads on this thing, I don't know, it might just be worth quickly swapping that one out. And check this out, there's another couple of 470 mics on there. Now, neither of these appear to be low ESR types. They're just, you know, ordinary crap electrolytic caps of whatever brand and model. And basically only 1 voltage rail difference there. And, you know, we're looking at 0.22 ohms there. So, you know, that's under the chart figure of 0.25, but still, you know, I don't know, red herring. I mean, you're really looking for these things to stand out. They should be, you know, grossly different. But when you're talking about an intermittent problem like this, it could mean that, often means that the capacitors could be on their way out, for example, some components on its way out, some components marginal, usually caps, because they got an electrolyte in them that dry up and increase the ESR on the things, especially when they heat up during operation and things like that. So you could be looking at a marginal value there, but once again, when you've got two side by side and they measure exactly the same and they're not in parallel, then, well, you know, you can be pretty sure that those two are okay. Now the problem here is that the symptoms aren't really consistent. I've had anything from, you know, not switching on at all, to not switching off at all, to getting audio through but no video, to the picture breaking up, we're getting red lines through it, all sorts of jazz like that. So, gee, yeah, I don't know. You know, BGA, could be a thermal thing happening with the BGA perhaps. Who knows? Yeah, nothing's really pinpointing this fault down to any particular area at all. So you just got to generally bum around hoping to find something. Well, I've powered it back up again, been playing around with it, and I'm getting nothing on the screen now at all. So you know, the backlights are working, everything's just fine. All those power rails look good, and you know, it's given the boot up thing and everything's hunky-dory. So I don't know, it seems to be getting progressively worse and worse pretty much. So not sure what the deal is. Anyway, I'm gonna have to leave it there because I've run out of time to do this, and well, yeah, I don't know, I'll have to have another crack at it. But my mum wants a TV back, and well, it could be I don't know, beyond economical time repair anyway, in terms of getting her TV back. So I don't know. Anyway, hope you enjoyed that. Yeah, sorry, it's a non-event again. People will be pissed off. Ah well. So if you're a bit peeved off I didn't fix it in this video, well, tough luck. Don't leave some stupid comment, oh, why didn't you fix it? Why didn't you upload the video? Unless you fixed it. God, unbelievable. I'll get people commenting like that anyway. Catch you next time.